Hi, welcome to the EEVblog, an electronics engineering video blog of interest to anyone involved in electronics design. I'm your host, Dave Jones. Hi, it's product review time again. This time around I've got an LCR meter. It's the Extech, let me read this, 380193. That's my first complaint. Product numbers. What is that? What's the deal? A 6-digit random number product number? Give me a break. Give it a decent name. Anyway, Extech LCR meter. Let's check it out. First up, a quick rant about LCR meters. Who needs one, right? Your regular multimeter can measure capacitance, can't it? Most can. These days, no problem. But very few of them can actually measure inductance, and that's what an LCR meter can do. LCR. Inductance, capacitance, and resistance. Sure, your multimeter can measure resistance, no problem, but a good LCR meter not only allows you to measure capacitance and inductance accurately, it allows you to measure other important parameters, sometimes important for your circuits, is that the quality factor, dissipation factor, the ESR, etc. of your components. So really, you should have an LCR meter in your lab. Now, this Extech one is $199 US, so it's very reasonably priced. It's in fact, I'd say it's pretty darn cheap for what you get. It's one of the cheapest full function LCR meters on the market. Let's check out what you get in the box for $199 US bucks. You get the LCR meter, bonus. You get a crap looking manual folded paper thing. I don't particularly like it that much. It's got the specs and most things you need, but yeah, it's a bit crappy. Not bowled over by that. You get the CD software for the PC interface, and you get the PC interface lead, the optical lead. So that's pretty good for the money, I think, for them to throw in the optical serial lead. Even if you don't ever use it, you've got it. A couple of standard 4mm banana plug to crocodile clip leads, as you'd expect. But that's it. So yeah, that's okay for the money, but it'd be nice if you got one of those SMD tweezer things these days, because they're all the rage. I'm not sure if Extech even offered that as an option for this meter actually, but it'd be nice if you could at least get those SMD tweezers. So the headline specs of this thing, well, it's about 0.7% accurate on inductance and capacitance, plus 3 counts, by the way, which that isn't quite as good as some of the more expensive ones on the market, but this is a lower price point, so that's fine, and it's pretty much all you need. Under 1% is great. It's certainly much better than a typical multimeter, which, you know, is going to measure capacitance to only a couple of percent at best. It's got 20,000 count display, which is really good. So it's basically a 4.5-digit display, which is awesome. It's got all the usual stuff you get on a typical LCR meter. It's got tolerance mode. Not only does it measure LC and R, it's got a dual display, which we'll go into. It can measure quality factor, dissipation factor, ESR, series and parallel modes. You can change the frequency. It only does 120 Hertz or 1 kilohertz. I was a bit disappointed by that. It would have been nice if it went up to 10 kilohertz, but it doesn't. It's got range hold, relative, high-low limit alarms, tolerance modes, all that sort of stuff. So it's not a bad meter for the price. It looks like pretty good functionality for 199 US bucks. Okay, let's take a look at the meter up close. Now here it is. As you can see, it's got a sort of a weird sort of functional angled I don't know look. It's got some sort of, you know, like it's some sort of industrial look. I don't know if I'm a big fan of the looks of it, but I guess it either you love it or you hate it, I guess. It's got some sort of, you know, styling with the ridges on the side like this, and anyway, whatever. It comes in a nice looking orange rubber holster, which is form fitted to it, and as you can see, it's got a dual display. The display is it's not the highest contrast I've seen, but they are nice big fat digits, so it is quite readable, and it's completely dual display. So you've got a primary display and a secondary display. The secondary display can actually display your quality factor. It can display your series resistance, your dissipation factor. So that's quite neat to have that secondary display up there. And as you can see, it's got pretty much buttons for everything. It's got a keypad interface for entering numbers with the enter key. You've got the power button, which turns it off and on. You've got basically a dedicated key for every function. Now, down here you've got the blade input terminal, so you can plug your components straight in, which is great. It's got standard 4mm banana jacks, but the big thing that's missing is a guard terminal, a shield terminal, which allows you to make up your own custom shielded leads, which go off to test jigs and things like that. So for really professional use, this probably isn't the best device out there, because for really long leads that go off to test jigs in some sort of automated test environment in a lab or a production line or something like that, you really need that shielded guard terminal. But hey, for general purpose lab use, it's pretty good. So it feels like a nice solid unit. It feels like it really could survive the bangs and the knocks. But the display, check this out. The display is, when you push one of these buttons up here, okay, the display is a little, I'm not sure if you can get that, there we go. The display, just pushing the buttons is enough to cause the display digits to actually fade in. So that's not the best at all. And one of the most annoying features, I'll start out with this, watch this, look, I'm pushing the buttons. I'm pushing those really hard, okay? I'm banging those. No response whatsoever, because you've got to hold them down for like half a second before it will actually do anything. It's useless. These buttons, they're hopeless. They really need to look into redesigning. It's just a software thing. It's just a software timing thing. That's all it is. So that's really annoying. One of the really annoying quirks of this meter. And on the top here, as you can see, it's got a 12-volt DC plug pack input. You don't get the plug pack, so you're on your own there, but it does have the optical RS-232 interface, which I had said you get the lead for that, so that's really quite neat. And on the back, it's made in Taiwan. There you go. I guess that's different to made in China. Go figure. It's got a tilt-in bail. It's plastic, but it actually stands up. There's a nice angle on it, and it stands up pretty well, and you can push the buttons and operate them without it falling over, so it's not too bad at all. When you do sit it down on the bench, can you move it around? No, it's got pretty good grip thanks to these two buttons up here, but there's no matching buttons down the bottom, so the bottom tends to slide around a bit more than the top does. So they should have just added a couple of more buttons down there, but I don't mind it at all. It sits on the bench nicely and it grips. It's pretty nice to use. There's one other thing that could be annoying if you're working if you're using it at your cubicle or something like that in a quiet office environment. The beep is quite loud for the button presses, so that's hard to show up on camera, but that's reasonably loud. I use that in the office and I feel a bit self-conscious really, but it's not too bad. It's got auto power off switch off, because these are quite heavy on the battery. It's got a standard 9-volt battery, which I'll show you, but if you hold down the power button when you turn it on, it says APO off, auto power off function off, so that disabled the auto power off and it's not displayed. There's no APO in the top window. So if you want to leave it on and chew the battery forever, then you have the option to do that, which is quite good. And also, one thing I really like is that it holds the last mode, okay? We're in inductance mode at the moment. There we go, Henry's, okay? We're measuring inductance, and if you switch it off and switch it back on, it will come back to millihenries mode. So let's go to capacitance, there we go. You switch it off, and you switch it back on, and it switches back to capacitance. Now, that's not to be underrated, that feature. I think it's really good, because if you're measuring capacitors all the time, for example, you're measuring inductors all the time, there's nothing worse than having to switch on the LCR meter each time and then go through the mode to get to the function that you actually want. So beauty, I like that. Now the 4mm leads which come with it, they seem quite reasonable quality. They seem a bit longer than your usual one, but they have a really nice solid sort of feel in there, and it feels like they're well fitted. They've got lots of grip and they wiggle a bit, but yeah, it feels like you get very positive positive retention in there. Now, let's check out, one feature we need to check out is the series resistance mode, because see how stable these things are, okay? Now, this is in ohms mode, and as you can see, it goes down to 1 milliohm. Beautiful. And as you can see, I wiggle the sockets around, even to 1 milliohm, you can see that even when I wiggle those sockets, it doesn't change at all. So that is really quite stable. I like it, it's excellent. And if you choose the relative function, you can zero that out. There you go. And that measures down to 1 milliohm easily. Piece of cake. Okay, now let's do a basic test with a simple 470 microfarad electrolytic cap. Now, I've got it in capacitance mode here. It's auto ranging. You can manual range with the range switch, but we won't do that. We want to test the auto ranging. I've got 120 hertz is my measurement frequency. The secondary display, I've got, I'm measuring the ESR, so it's got ohms. There's a little ohm indicator up there, as you can see, and we're in series measurement mode. So let's plug the capacitor in. It plugs in. These blade terminals are quite nice. They seem fairly good contact, and as you can see, it takes a little while on the auto ranging, but it's no slower than other meters on the market. And as you can see, my 470 microfarad cap is 541.7 microfarads with a series resistance up there of 0.23 ohms. Now, if you wanted greater accuracy, greater resolution on that 0.24 up there, all you've got to do is switch into series resistance mode, and there it is, 0.275 ohms for the series resistance of that capacitor at 120 hertz. And if you want to change the frequency, you can do that. The frequency up there at 1 kilohertz is 0.121. So as you can see, the frequency makes a hell of a difference. Now, normally the ESR of a capacitor is measured at 100 kilohertz as the nominal figure for that. But this one only allows you to go to either select 120 hertz or 1 kilohertz, which is a bit disappointing. I would have liked to have seen at least, say, a 10 kilohertz mode, but for the price, you can't complain. It works really well. And it does have a backlight feature. There's the hold button down here. You hold it down for 2 seconds and bingo, the backlight comes on. It's a green backlight. It's pretty weak. Trust me, that's not the camera. It's a pretty weak, piss weak looking backlight. I don't like it, but hey, at least it's there and it's probably not drawing too much current. We might measure that later. What are the minimum values it can measure? Well, in capacitance mode at 1 kilohertz, you always go to the highest frequency when you want to measure the lowest possible values. It's 0.1 picofarads. I'm a bit disappointed with that. It would have been really nice to go to 0.01 picofarads resolution, but hey, you know, for the price it's not too bad. Ohms, of course, you saw it went down to 1 milliohm before, so we won't do that again. And if we short it out, the inductance, as you can see, goes down to 0.1 microhenries. Now, if we change the frequency there, 120 hertz, you see it's only 1 microhenry. So you've got to go to that 1 kilohertz range to get your greatest resolution value. 0.1 microhenries, that's okay. Once again, I would have liked to see a bit more than that, but for the price, not too bad at all. Now, as you can see there, 0.1 picofarads, 0.1 microhenries, and 1 milliohm resolution really blows away a standard multimeter. Even if they do have LCR capabilities in your multimeter, these things are much more valuable. A dedicated LCR meter is much more valuable for measuring small values of components which you typically might find in, say, RF work or something like that. So real handy to have one of these LCR meters in addition to your regular multimeter. And it's got regular min-max average recording functionality as well. So in any mode, you can just hit the min-max record and it says R up there. So we're actually recording now. So you can actually take a value and it will beep when it's found, there we go, it's probably found the upper value, but it doesn't auto range. It won't actually switch ranges while you're in that recording mode. There we go, it's just recorded the minimum. So now we can hit the min-max button. There's our maximum value, 107K. Our minimum value, 0.00K. It didn't switch ranges, which was a bit disappointing. And the average min-minus max. And the bloody buttons, I hate them. And the average value, 53K. So there you go. There's one really annoying feature I don't like. I'm in the tolerance mode here, entering the tolerance value. It's a little bit complicated, but look, the power button does not work when you're in this entry mode. You cannot switch it off. You've got to finish doing the entry mode before you can turn the power off. That's crazy. I won't spend the time going through and showing all the other modes that it has, like the high-low limit alarms and the tolerance. It's got quite flexible tolerance modes where you can enter values and get the difference from an entered value and stuff like that, which really is quite flexible, but I won't spend the time. You can have a look at the manual, which tells you all about that, but it's a pretty flexible unit. I like it. Now, here's the meter without the rubber holster on it, and I noticed a weird sound inside. There's like a twanging sound. It goes twang anytime you hit it. I'll hold it up to the mic and see if I can get it. Listen to this. See that? So it's obviously some there's like a metal internal shielding spring or something like that inside, or some extra shielding in there that's just loose, and it's just going twang. Now there's one slightly annoying thing about this. Because it doesn't have a very long battery life, you have to take the holster off to access the battery compartment. I find that a bit annoying, but it's not too bad, I guess. Now they've got 2 screws here for the battery compartment for the 9-volt battery, and 2 screws up here to open the case. So let's take a look. Battery compartment uses standard self-tapper screws. It's not too bad. They're the good quality type, but look, how do you get this battery compartment open? It's one of these, there's nothing to sort of get your fingernail under or your finger under and lift out. You've got to sort of pop it open like that, and it's really quite annoying. But anyway, here's the 9-volt battery. They give you a Mitsubishi 9-volt battery with it. I don't even think it's alkaline, so that's a bit cheap ass, and it's just got a standard 9-volt battery snap, which yeah, I'm not a big fan of. It's one of the cheap quality ones, but you know, at least it's accessible, but not as accessible as I'd like. And to get the case open, they've got the standard self-tappers here, same as these ones, but there's none down the bottom. This bottom battery cover screw actually holds in the case. So let's open it up. I've fed the battery snap through there, so if you want to get the case completely open, you have to feed that battery snap through, but there it is. And as you can see, there's that metal work. There's that metal work that was going twang. And let's take a close-up view of the board, shall we? Here it is. And I'll take you all the way along the board. The construction is very, very nice. I like it. It really is quite a decent quality. There is, on the joints there's some solder residue. There's some paste residue there on all the pins, as you can see. So that's not too great, but that's not uncommon really in these sort of you know, lead-free construction instruments and stuff. There's a TLC. Let's see if we can see that. There's a TLC 7135. I'm not sure that's a TI part. I'm not exactly sure what that does. It's probably an ADC, I would suspect. Given the big sampling cap next to it here, I would say that's the ADC, but I'd have to check on that. No surprises whatsoever. It's a TI MSP 430. Not sure if you can get that up there, but yeah, there it is, TI MSP 430 processor. They've got a code in here. It's a Xeon 2. I'm not sure what that actually means. It's probably the code name for the actual product. Now down here is the ISP programming header by the looks of it. COM, and then they've got TX, no, there's TCK, there it is, TCK down the bottom. That's probably the JTAG interface for the for actually programming the device. So that's readily accessible. A few SMD electrolytics down here, but pretty much all standard Jelly Bean component stuff. I really like it. But that's fairly common for these class of LCR meter instruments. Now, let's take a look at the input jacks here. They're very nice. They're actually folded metal like that, and they go down through the bottom of the board, and then they're bent back up on the bottom of the board and soldered at both points there and there. And they're really quite nice. I like them. And as you can see, a spare fuse. Look at that. They've given you a spare fuse, which is quite thoughtful. And there's the input fuse there. There's a poly switch. There it is, a PTC poly switch. So it's got some input protection. And it does tell you if the fuse blows. The firmware can actually detect that the fuse is blown. It will actually display fuse up on the screen. There's a little trim pot there. But that trim pot looks like the only adjustment, and there's a jumper switch here which says cal. That's obviously move the jumper switch over to there, you put it into calibration mode. But apart from that, we've got the input board here. That's got the RS-232 optical interface plus the 12 volt power supply and voltage regulator up there. This is tacked on. Look, that's a bit bodgy. That's a surface mount footprint there, and they've just tacked that on. That's pretty rough as guts. I don't like it. So overall, the construction quality is reasonable. They really do need to work on their cleaning process for the board because there's lots of leftover residue on there. I don't really like that. There's the odd dodgy cap in there. You know, the wires over to the piezo transducer over there are a bit bodged on and delicate, and you know, but it's okay. It's a reasonable construction quality for the price. I don't mind it really. And because the manual doesn't give us the battery specs at all, the battery life or anything like that, let's check it out. I've got the MetroHit Extra here measuring the battery current. As you can see, I've got it in standby. It's drawing about 18 microamps, and the MetroHit World over here is measuring the battery voltage, which is 9 volts coming from my power supply over there. So it's on standby mode. 18 microamps, which is pretty darn good. That's going to last a couple of years on standby mode, so that's quite low. So let's switch it on. And as you can see, it draws about almost 12 milliamps during normal operation. Does that change during modes? No, it seems pretty consistent between the modes. So let's turn the backlight on, and it almost doubles there because it's a really weak backlight. So it's only drawing about 10 milliamps extra for the backlight, which isn't too bad. But 12 milliamps power consumption, that's probably going to give roughly 50 hours of regular operation at least, I'd say. Around 50 hours. I don't think it'll make 100, but it should do around 50 hours. So that's not too bad. Now, there's one more thing we need to check is what value battery voltage does it drop out at. Now the battery symbol will come up in the bottom corner here, so let's wind the wick down on our external power supply until it comes up. Oh, there we go, about 7.4 volts, which isn't that great. That's only about 1.2 volts per cell for our 9 volt battery, which I've seen worse than that, but I've certainly seen a lot better, and it should be a lot better. So they are pissing away quite a bit of the power in the 9 volt battery. So it may not get that 50 hours battery life we were talking about. I don't know, you'd have to actually do a full term test on that to make sure, but yeah, I'd rate that as a little bit on the poor side, really. Now, I won't bore you with all the details about how it seems to meet the specs on all the components I measured and all the ranges and things like that, so we won't bother, but I'll just do a quick test here with the surface mount inductor at 1 kilohertz, and this does compare well within spec to other LCR meters. I've got 1055 microhenries. Let's have a look at 2.6 ohms series resistance. Let's go in there and change that. There we go, almost 2.6 ohms series resistance at 1 kilohertz. So let's just confirm that with our regular meter here at DC. And there we go, 2.5 ohms. So that's not too far off at all. And I just thought I'd see if I could confuse it by putting another 10 ohm resistor in series with it. And there it is, 12.6 ohms, no problems at all. Switch it through to microhenries. It's still there, and it's but it's showing a series resistance of, there you go, 12.5 ohms, no problems at all. And if we switch that over to our meter over here, our regular multimeter, there it is, 12.4 ohms, no problems. And just for fun, let's see how good the shielding is. I'm on a call here, let's do the standard mobile phone test, shall we? That you can pretty much test for all sorts of instruments. So I'm actually calling, so this is transmitting, and it's doing nothing at all. Check it out, really nice. I like it. And let's just do the same test again with the leads attached. No problems at all. It doesn't change a thing. One thing you have to consider with these LCR meters are the specs. Now the specs of its basic accuracy spec of 0.7% plus 3 digits is only going to be met in the middle ranges, and this is the same for almost every LCR meter on the market. So just look out, check up here. This is a 10 millifarad range of capacitance at 120 hertz. It's 5% plus 5 counts, and once again on the lower range down here it goes up to 1% plus 5 counts, and it really only meets its basic spec of 0.7 plus 3 in the center of the ranges. And there's the capacitance at 1 kilohertz, there's your inductance, and it changes with frequency, so, and it'll change with series or parallel mode as well. So it's just something to look out for. So it'll only meet its basic specs pretty much in the middle. Just something to consider when you're looking at LCR meters. If you're comparing the specs of them, make sure you just compare the specs in the outlying ranges as well, and watch for those plus counts too. Let's have a quick look at the software that comes with it. Now, when you install it from the CD that you get with it, it installs the National Instruments LabVIEW runtime driver. So we'll have to install that before we can talk to the meter. Okay, we start it up and we get the Extech instruments here. It's called the virtual meter. So let's start the instrument, and well, we just get some silly looking, well, nothing. Please check COM port parameter. No, nothing. Zip. Can't automatically connect. Set COM port. Here we go. COM 2. Let's try COM 1, shall we? And set instrument. Save to default. Okay. And there we go. Boom, it's talked. Yeah, it's loading, and bingo, there it is. It switched modes. It was measuring capacitance before, so it automatically switched to inductance. Let's see if we can, if it reflects up here. Yep, it does. So there you go. Now let's go from parallel to serial mode. Yeah, parallel mode. It does reflect all that. It's not displaying the secondary reading up here. I don't know why it's not doing that. Check it out. Let's switch back to series mode. There you go. It displays that, but it doesn't like displaying that secondary value up there. I'm not sure what's happening with that. And let's check out this record functionality. It looks like you can actually plug values in here. So I'll plug a bunch of different caps in there. And as you can see, it updates in real time there. And I'll hit record, and it looks like it's recorded a value there. Let's try another capacitor. They're all the same, but they will have slightly different values, of course. And let's record that. There you go. I was actually able to call up a list, a spreadsheet list of the values I actually recorded. There's the 5 values. There was 4 dummy values before it, but you can actually export that to an Excel compatible spreadsheet file, so you can get the data out. I'm not sure if you can actually write your own software. It comes with a dev kit to actually talk to the protocol to suck your own data out automatically as part of an automated production test or something like that. I'm sure it's possible, but I didn't see anything in the software that actually allows me to do that. So it's got basic rudimentary recording capability and duplication of the actual instrument. You can't actually record, you can't actually control the instrument from here by the looks of it. But you can actually get the readings out of it, so it's okay, but nothing to write home about. So there's a quick look at the Extech 380-193 LCR meter. It's only an entry-level model, so you've got to look at it from a price point of view. It's $199 US, which I think is pretty excellent value for money. It's not that much more expensive than some of the other simpler El Cheapo 100 low brand LCR meters out there. So it's pretty good. It's only got 12-month warranty, so you know it's not going to shake the earth there, but it's reasonably accurate. It's not the most accurate LCR meter out of the LCR meters I've got here, but it's certainly the most affordable. So you've got to look at it from that affordability point of view, and I think it really is pretty good value for money for an entry-level LCR meter for your bench. It reads pretty stable. It reads fairly accurately compared to my other LCR meters out there, and I don't mind it. It's got a few annoying features which bug me. The buttons, the auto ranging is fairly slow on it, but it seems to work, and it seems to work pretty well. For $199 US, I think you should take a look at it. I like it.